How is the Madden-Julian Oscillation helping the North Pacific? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 10th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time. No hype. If you enjoy the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. If you have a question or comment, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with a $sign in it. With that, I'd like to thank the folks that donated last week. Tim Caston, Our Predicament, Evolution Moto, our longtime contributors. Thank you all so much. And then Pierre Morton, Ryan Boston, Peter Carpenter, Lake Surfer, and WWD Photography. These are some new contributors. Thank you very much. We do appreciate your generous contributions. And with that, let's get to work. We'll start by looking at significant wave heights for the entire planet. Starting in the North Pacific, we have two gales in play, one with 29-foot seas in the Gulf of Alaska it was targeting Hawaii. Now it's focusing primarily on the Pacific Northwest down to North and Central California. And another gale developing just west of the dateline with 25-foot seas and expected to build as it pushes off to the east. So it looks like winter is starting to finally really set up in the North Pacific, and that also keys into the title of this video. What is driving the sudden change in the North Pacific, and will it last? We'll see as we get deeper into the video. South Pacific, it's November now. Things pretty quiet. A little gale with like 23-foot seas, but not doing anything meaningful in terms of producing swell relative up into Hawaii and the U.S. West Coast. North Atlantic, gales trying to develop off of the northeast U.S. coast. Might produce some swell. We'll see in a little bit, but most of that would probably be targeting more towards Europe than back at the coast here. South Atlantic, pretty quiet. It is that time of the year when things are winding down. Indian Ocean, a little bit of activity forecast, but at the moment, a small gale with 28-foot seas well south of Madagascar. We'll see how that plays out in the forecast section of this video. But let's start by taking a look at current conditions. We're going to start up in the Pacific Northwest, Grays Harbor, Washington, buoy 036. We're looking at all the energy that is hitting that buoy all the way up from 33.3 second period, very long period energy, which there is none, whole way down to 5 second period, just pure wind chop, a little bit there. But we see a bump here in the 12 to 13 second period range, 2.9 feet, 2.7 feet. It is the area not just at one spot, but it is sort of off on the shoulders and the main core that comprise what is typically described as swell. In this case, primary swell, 4.7 feet at 12.6 seconds from 276 degrees, so pretty much out of the west. That would theoretically make surf at about 5.9 feet. And then some wind swell thrown in there too, 2.8 at 9.2 seconds, again from the west. 2.5 foot surf, but that would be completely buried in the primary swell. Also looking at the chop height here, 2.3 feet. Anything more than about 1.5 feet, you definitely get a pronounced warble in the water. 1.5 feet's not too bad. 2.3 feet, a little bit warbly. When you get up into the 3-foot range, it's a mess and pretty much unrideable. Then we go down to Northern California, same deal, starting at Point Reyes, buoy number 029. Much more swell hitting here. This is actually the same swell that was hitting up there in the Pacific Northwest. Just takes a day or two to work its way further south. And as expected, the swell height is bigger, but basically the same profile. Nothing out in the super energetic side. Not a whole lot of wind swell. That's a good news. Primary swell, 7.1 feet at 13.4 seconds from 302 degrees. That's theoretically surf at 9.4 feet. That might be a little bit on the high side, but it's in the ballpark. And there was definitely surf in the 8 to 9 foot range the day before on Saturday. So there is finally some semi-real swell in the water. The chop height, 1 feet. Yeah, it's really clean. Not a lot of warble. Good day for surfing. Then down to Southern California, Point Loma South, Buoy, number 191. This is off of San Diego there. Again, the same sort of profile, but the swell about a day behind what's happening in Northern California. Really, this is probably the peak of the swell. You notice the peak energy here at 15.4 seconds, and the swell size attenuated a bit by the Channel Islands. Primary swell, 3.3 feet at 14.8 seconds from 259 degrees. That includes some wrap caused by the Channel Islands. Surf heights, 5 feet. Might be a little bit on the high side there, but you get the general idea. Chop height, non-existent, 0.7 feet. So whatever swell is getting in, quite clean indeed. Then we go over to the north shore of Oahu, Waimea Bay. Same swell hitting there, but about a day and a half older than what is hitting Northern California. It's freshly hitting Southern California and all but fading out in Waimea, or actually the north shore. Primary swell, oh, here, let's go look at the graph, I'm sorry. Here you go, period down to 11 seconds. So classic deal. When the swell first hits, you get the longer period. You saw that down in Southern California with the 15-second period dropping to 13 seconds up in Northern California, down to 11 seconds in Hawaii, and pretty much the same deal up in the Pacific Northwest. All right, primary swell height, 3.5 feet at 11 seconds and 318 degrees. Sideband energy, pure swell, I mean, projected surf size, 3.8 feet. Well, it was, you know, that's sort of what you'd call Hawaiian scale. There's a swell enhancing bathymetry, the reefs that they actually make the swell bigger than what it would be from just a pure ocean standpoint. This is pure open ocean swell and calculated surf heights from that. And indeed, surf was a foot overhead at many breaks on the north shore of Oahu today. And chop height, 1.9 feet. There was definitely some warble in the water. Local wind swell is the guess. Yeah, let's see if we can see. Oh, yeah, you can see it down here. You see a bit of just this steady 1 to 1.5 foot like lump in the 9 second, the whole way down to almost 6 second range. So that explains the bump, probably coming from the north. So we didn't do a video last week, so we're going to roll this back 2 weeks at least for the North Pacific. And that is also germane to part of this discussion about the MJO because, well, the active phase of the MJO started mid-October, something like that. We'll take a look here in a minute at the actual MJO Hindcast charts. But that's about when swell started developing in the North Pacific. So we're back to Friday, October 25th, 2 weeks ago. Gale in the Gulf of Alaska produced 28-foot seas. That produced some north angle swell relative to California. You can see it hitting there. That was on Monday, October 28th. And then another gale developed behind that. Again, this one with 28-foot seas, very north-angled swell. That hit into Northern California on Thursday on Halloween night. Another gale behind that, much stronger built with, what was that? Let's see, 43.3 feet right there, the highest seas over this entire domain. And I think it actually got high. There we go, 46.8 feet and up to 48.2 feet. That produced north-angled swell that pushed into Northern California sometime later. Let's see, you can kind of eyeball it there roughly. Sunday, Monday, November 4th. And then yet another gale developed here with it says 35-foot seas, but that's really over here. You got to read the coordinates and map it out. But we'll say 32-foot seas on Tuesday, November 5th. That produced a little bit of swell that pushed into the coast. Let's see, that would have been on Friday, I think. And then another gale right behind it with 27-foot seas on Wednesday, Thursday of this week. That swell hit on, you can just see it right there, on Saturday, and is the one that's fading now here and starting to build in Southern California. And now we are at just about current time here. There we go. And you can see we have yet another stronger gale developing in the northern Gulf of, or we'll call it the northwestern Gulf of Alaska, and yet another system out by the dateline. All this making a pretty decent run of surf. It finally looks like winter, at least in California. Hawaii getting sideband energy. A decent pattern is setting up. For the South Pacific, while things are really winding down there, it's becoming summer in the southern hemi. We'll just go back a week here to November 3rd and we'll blast through this. We had a little gale there off of Chile with 26-foot seas, produced some surf there, but since then, pretty quiet pattern. We're looking for anything relative to our typical summertime thing. You'd want to see like 30-foot seas. We're not even close to that. Here we are. We're all the way out to Sunday now, current time. Nothing happening. No big surprise. North Atlantic. So you look at the, and I'm looking specifically relative to the U.S. East Coast. You would typically, the wave models, that's what we use in like the U.S. West Coast. But the wind models actually tell a better story in terms of potential for surf. Anyway, relative to Florida, there's been this consistent easterly, northeasterly wind and wind swell being producing surf all along the Florida coast. Yes, a bit windy, a bit choppy, but there definitely have been waves. You see the wave model shows, what is that, sea heights, 10 to maybe 12 feet. And that's certainly enough to produce well-rideable surf. But the wind models kind of tell it better. Anyway, looking out what happened on Wednesday, gale wound up here off of Ireland, but pretty much going north. Sideband swell pushed into the coast there, 26-foot seas. Another one even more sort of twisted, didn't do a whole lot on Friday for making surf. And then Saturday, we're just seeing this. Now here is another gale developing off the U.S. West Coast. You notice all energy pushing more towards Europe than towards like Florida, southeast coast proper. The South Atlantic for the past week, we'll just blow through this little gale with 28-foot seas pushed under South Africa, has produced swell. You see the swell front radiated up into South Africa on Thursday and Friday. I think there's another one, there we go, starting to build as we get into Sunday. Nothing huge. Again, it's sort of that time of year where things are settling down in the southern hemisphere and everything appears to be focusing more on the northern hemisphere. And then finally, the Indian Ocean. We'll play this out for the past week. Again, you would think things would be quieting down, but there still has been. There is a little gale with 28-foot seas generating energy radiating mainly towards Western Australia, maybe a little bit up towards Bali and the Mentawai Islands, but really a southern Australia focused kind of storm. Tasmania was in the target here. This was swell arrived on Friday, November 8th. And let's see, we go to Saturday and here's Sunday. Here's that other system pushing under Africa. But again, a quieting pattern going on in this area. Next up, we'll do a drill down for the North Pacific, but you can go on stormsurf.com, see the same models for whatever ocean you happen to be living on or are interested in, and use what we teach you here to build your own forecast. All right, so we're looking at Jetstream level winds. It all starts up in the Jetstream. These are winds up about 30,000 feet. These winds help create or support the formation of gales. When those gales form, help direct their track. See the winds here. Oh, let's get it. The Aleutian Islands here, Alaska, down into the U.S. West Coast, Baja down here, Mexico, Hawaii right here. The jet stream split pushing off of Japan. That doesn't do anything to support gale development. Then you see a bit of a trough trying to dig out. That is a dip in the jet to the south. What that does is help create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And low pressure, of course, if it's strong enough, gets traction on the ocean surface, generating winds. Those winds help create seas. Those seas build, and as they radiate away from the fetch area, the lesser period, the shorter period elements of that raw sea state decays off. The longer period elements keep going, and that creates swell, which eventually, when it hits your beach, creates surf. So we have a little weak trough here over the dateline, a far stronger trough digging out here in the Gulf of Alaska, winds up to 190 knots, that bare little shade of gray right there. So that's a pretty healthy jet stream supporting gale development. You see it's supposed to dig out as we get into Monday, the 11th of November, before pushing on onshore over the Pacific Northwest. The next trough, most of its energy is here in like the south quadrant. You really want to see that energy falling down into the northwest and west quadrant of the storm. But still, this looks likely to support some sort of gale development. And indeed, that gale looks much better Tuesday as it pushes into the Gulf of Alaska, being supported by 140 knot winds, again down on the southern quadrant of that storm. Continues, if not building and expanding, as we get into Wednesday, the 13th of November. Notice the jet pushing onshore over northern California and even into the Tahoe area. That is good for weather. We'll be talking about that in a minute. And by weather, I mean snow and some liquid precipitation. Backdoor trough sets up off the U.S. West Coast, pushes into northern California on Friday, November 15th. Not much for surf, but again, the weather thing. We're interested not only in surf, but in snow in the higher elevations. And then you see this big ridge here. That supports high pressure. When you see that, you can pretty much assume there's a whole batch of north winds likely coming right behind after the trough moves inland. Then we're out to Sunday, almost a week from now. Well, exactly a week from now. And you see the jet, the split pattern, still sort of present here in the west, but it's consolidated from the date line off to the east. Another trough digging off over the date line. We can get it to here, to Sunday night. This trough looks much better with the 18Z run of the model than it did the 12Z run, suggesting that perhaps there is still some surf yet to come. We'll see how the MJO affects all of this in the long-term section of the forecast about halfway into this video. But the thought is it is having an impact for sure. So that was Jetstream level winds. Let's get down to the ocean surface, because it literally takes winds blowing on the ocean surface, creating raw seas to generate swell. And right now, here we are, surface level pressure, surface level winds, a gale with, I can't even read it, let's say 974 millibar low in the Gulf of Alaska, generating 35, 40 knot northwest winds targeting the U.S. West Coast. This low pretty much past Hawaii now, but the second in the system also generating 40 plus knot winds targeting Hawaii well. That is as of today. As we get into tonight, look at that little tiny area, 55 knot winds on the date line. That is a good sign. The gale continues in the Gulf of Alaska. Another system, there's tropical systems, a bit of activity going on here. Whether any of this recurves, well, probably not, but we'll see. So we get into Tuesday, the second gale pushes into the Gulf of Alaska with 35 knot winds over a broad area close to shore, making for probably some larger raw kind of swell. Now here we go, we're out to Wednesday. Another gale tries to spin up here towards the date line, lifts north. Let's see if it falls. Nope, it doesn't. It's up and lost into Alaska. High pressure in control at 1036 millibars. This is on Friday, but here we go, yet another gale. So we get into Saturday. Now, this is a week out with what, 45 knot northwest winds? Yep, 45, continuing. Let's get into Sunday. Here we are. This is a week from now, the 17th of November. Continuing, looking like it's bound for the Gulf of Alaska. So the pattern so far this year has really been kind of dry out here in the west. By dry, I mean not a lot of swell-producing storms. The focus is all the northern Gulf, which is pretty typical for early season, though, you know, it's November and we're talking normally what we'd be seeing in September or early October. So we're running about a month behind schedule here. That said, pattern has been really focused in this area, but we're now starting to see some activity out by the date line. And all in all, given that we had El Nino last winter and La Nina supposedly this winter, so far, we're doing okay. Now, when was this? Months ago, we were forecasting that the beginning part of this fall would probably be better than as we get deeper into winter, because the hangover from El Nino would still be circulating in the upper atmosphere. That'd be fueling storm development, and specifically in this region. We'll see if that's still going to hold true. But for now, things looking pretty active. We'll take whatever we can get. So what is the effect of those winds on the ocean surface? Well, here we are, 18Z Sunday. That's really 10 o'clock local time, Pacific time. 29-foot seas in the Gulf of Alaska. It says 31.5 feet here, but that is associated with, I think, this system here. You can 16 north, yep, right there, 123 east, yeah. So tropical systems here, but you see, those are little dots compared to these big lumbering giants here in the North Pacific. Much more effective if you have wind blowing over a broad area, much more effective at generating seas and swell. So 29-foot seas in the northern Gulf of Alaska, our next system, winding up on the dateline, producing 26-foot seas over a small area. Get into Monday, whoops, we'll go right there. Right before sunrise Monday, actually late Sunday night, 31-foot seas in the Gulf of Alaska, but seas building to 35 feet here on the dateline, building to, again, 35-foot seas on the dateline, continuing at 33 feet as we get later into Monday, and then fading from there. But this gale still continues pushing off 25-foot seas into the Gulf of Alaska Central and pushing in towards the Pacific Northwest. Now, we know there was another gale forecast over here, and you know what? Hawaii will probably get some surf from this thing, even though it doesn't last very long. It basically it just shuts down. You can actually see the swell front there pushing towards the Hawaiian Islands, assuming all this forms as forecast. But then a week from now, here comes another gale with 31-foot seas over the dateline. Oops, and that's as far as we go. The models actually go out 2 weeks. We don't show it here because, honestly, more than a week out, the models are so flaky. You know, you're lucky if you get 50% of what is projected a week out on the models. And 2 weeks out, it just turns into pure fantasy land, a bunch of hype that never materializes, and we're not really into that. So for now, we'll give you a tease, say maybe 30-foot seas approaching the Western Gulf a week from now. I wouldn't bet a penny on it, though. For fun, we'll go take a look at the South Pacific. We'll just run through this real quick, see if we see anything of interest. Now, relative to Patagonia, Chile, up into Peru, there is 34-foot seas. That's certainly capable of making some sideband swell pushing up to the South American coast there, but nothing relative to California or Hawaii. And then after that, things really quiet down. We're a week out. Current image from the North Atlantic, significant wave heights again. Yes, there is a gale trying to develop here off the U.S. West Coast, all fetch aimed off to the east. This really is not even Europe proper, maybe more just like North Europe at best. So certainly some swell should result from that gale. Looking out beyond, we're looking for anything to really organize. Now you see something way up here in Barents Sea or something like that for, was that Norway or Sweden? But not anything that is for our forecast area, and I claim to have no expertise on the surf in that area. But North Pacific, it's trying, but really not getting any full winter traction yet. South Atlantic, we'll run this through again. Things quieting down, but there we go. There's a gale with 42-foot seas forecast on Tuesday, the 12th of November. That you can see bits of energy pushing up towards South Africa and into the Indian Ocean proper. And another one theoretically behind that with 39-foot seas, tiny little system, but again, that should produce some swell pushing up into both east and west sides of, well, mainly probably the west side of South Africa. And let's see, we're out to Sunday now, November 17th, and a quieter pattern after that. And our final stop on the global tour, the Indian Ocean, looking at the forecast for the next week. There's that gale pushing under Africa, again with 40 up to 44-foot seas, but then it quickly fades. So that's good. A little backup energy behind that. That's still good for longer period, probably pretty well spaced sets up into Indonesia and Western Australia. Another gale forecast with, well, where was that? Right about there, 36, maybe 38-foot seas for a moment, but tiniest of tiny gales, not a big fetch area. Local system for Tasmania on Sunday, a week out. And then, whoops, there we go. That's a week, and that is it. That's a wrap. The South Pacific, or south in the Southern Oceans, slowing down, definitely, as specifically the North Pacific, seems to be taking the cake, at least for the next week. Local wind forecast for California. So there's Point Conception, Southern California down there. San Francisco Bay Area right there, up into Cape Mendocino. Hawaii here. So high pressure trades in control for Hawaii. Low pressure filling the Gulf of Alaska. Light wind regime for California for the moment on Sunday. So we get into Monday, you see a front starting to push down the coast here. Not a particularly strong one, but nonetheless, some winds probably expect along the coast. High pressure building trades nearly 20 knots pushing into the Hawaiian Islands. On Tuesday, things settle down a bit. A little bit of high pressure tries to get a nose in the door relative to Central and North California, but the window between north winds there and south winds there, it's the difference from, where is that? Let's Point Arena, northward south winds, Monterey Bay, southward, pretty strong north winds. High pressure, look at this fetch of trades pushing into the Hawaiian Islands the whole way from Mexico. East wind swell possible for that. Next low nuzzles up to the California coast. On Wednesday, 13th of November, lighter wind regime, at least for a minute, unless you're north of Point Arena, and then south winds and controlled trades, pretty much nuking for the Hawaiian Islands. Thursday, things back off a little bit. A lighter wind regime, though. You can see high pressure at 1036 millibars, poised to push into the coast. Solid fetch of 20-plus knot east trades for the Hawaiian Islands. Same deal on Friday. California being spared in the morning from nuking northwest winds, but probably blowing a bit. And then as we get into Saturday, fortunately, the high just sort of seems locked. It doesn't fully push onshore, but northwest winds on Saturday, 16th of November, 15 to maybe 20 knots. And again, the hard trades just pushing into the Hawaiian Islands. Now, remember, the jet at that time ridging hard north out here. That's what's feeding that high pressure system. So we get into Sunday, again, same sort of pattern, nuking northwest wind, trades for the Hawaiian Islands, and a modest northwest wind regime for California. And there we are into Monday. You see the high pressure looking ready to get pushing into the California coast. Yes, a gale potentially behind that. Trade still, though, blowing hard for the Hawaiian Islands. All right, precip forecast for California. Yes, we are in that season finally. So we'll get into Monday. You see a cold front starting to hit the northern California coast, Cape Mendocino, pushing down to Monterey Bay mid-morning and down to Point Conception with rain and snow for the Tahoe area. This is tomorrow on Monday. The 11th of November. That backs off, a little bit of a dry out, but then here comes the next front doing almost the same thing on Wednesday, pushing south, snow down to Tahoe. Doesn't get any further south, and the rain only makes it to, maybe Santa Cruz if you're lucky. Thursday, another little pulse of something tries to organize. Rain get down to the San Francisco Bay Area, but pretty light, spotty, fading. Snow, theoretically, Friday for the Sierra. Now, this is not some big snow event, just early season. There is actually snow on the ground from about 8,000 feet and up. I was looking at the cams there, and there's snow on the ground, 4 or 5 inches, depending on where you're looking now. That's from maybe a couple days or a week ago. Where the sun gets good exposure, a lot of that's melting off, but in the shadows, north-facing aspects, still, snow is there. Temperatures are down. The ground is getting primed to receive snow. We're making the slow transition towards winter. Put this in motion further. We'll run this out. Theoretically, another batch of rain on Monday or Sunday night, a week from now. We'll see whether that materializes again. It looks like a backdoor slider. You can tell from just how much snow there is up here in the mountains. In fact, the Mount Bachelor area and Mount Hood, they've got a pretty good amount of snow. They've gotten a good amount of snow over the past couple of weeks. The snowpack is building. This is pretty typical of both early season and La Nina, the snow line from the southern border of Oregon northward. And then systems have a lot harder time making it further south. We'll see whether that pattern continues or whether our La Nina kind of weakens and allows more moisture into California. The snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley. What's that, about 15 or 16 inches? Let's see if we can pull this up here. There we go. Oh, 18 inches, 1.5 foot forecast. We'll go back now. So you can just see, and you can see a bit here on Monday, the 11th, a little bit on the 13th, and then more on the 15th. So a slow, steady accumulation pattern. This is the I looked at the 12Z run of the model. It was basically the same thing, give or take an inch or two. The interesting part here is the snow level. In fact, let's see if we can blow this up a little bit here so you can see it better. So this is the base of Palisades Tahoe at about 6,200 feet. This is a summit up at about 9,000 feet, the top of the Palisades. The blue is 28 degrees or lower. The white is 32 to 28 degrees. That's freezing. The gray would be sleet. You can get sleet at, you know, like 35 or 36 degrees even, something like that. We went conservative over here and said sleet is 34.6 degrees, but, you know, it depends on a bunch of different situations. Anyway, the point being, the snow level, the hard freeze level, falling below the base of Palisades Tahoe, dropping down to 3,500 feet the night of, I think this is Tuesday night, the night of the 11th, then back up above the base, but then falling again down to, what is that, 3,200 feet on the night of November 15th. I think that's Friday again. But then after that, you see this kind of steady build up, temperatures up to 1,100 feet or 11,000 feet. Again, when we start getting into the MJO discussions, some of this will become a little bit more clear what's going on, and we'll talk about it. And that forecast was pretty representative of the Tahoe Basin. Now, further south, Mammoth, you see nary a drop. This morning's run of the model had a couple of inches of snow there, but not nearly as much as up north. The reason being these are backdoor slider systems. They're falling from north to south down the spine of the Cascades in the Sierra. By the time they get down to Mammoth, it being early in the year, the systems are just wrung out. There's not a whole lot going on. But you do see temperatures. There's the base of Mammoth at 8,000 feet, a lot higher, the summit up there at 11,000 feet. But you still see a 3,000-foot freeze level on the night of November 11th. And again, the same sort of deal out here on the 15th, 16th. So winter is coming to the Sierra. All right, spot forecast. We're just going to go do a sample of areas. We'll pick up North Oregon, Columbia River in general. This is not for any break-in specific. It could be anywhere. 20-foot swell or surf height, calculated surf height, the combination of swell height and period, producing 20-foot surf. This is not in counting any bathymetric enhancement. It just assumes a standard beach break sort of scenario. So 20 feet there on late Monday. It's really pretty much Tuesday at 5 a.m. sort of thing. That swell dropping off. You notice that lots of wind, 20, 30, 40 knot winds out of the south there. Then another pulse of surf coming in on Thursday at 18 feet, winds still out of the south. Finally, winds backing off some as we get into Friday and maybe the early part of Saturday. Then the wind machine kicks up again. Swell heights, 13.7 feet at 16 seconds on the first one on late Monday, early Tuesday. Next one pulling in at about 12.5 feet at 14 to 15 seconds on Thursday, and then a downward pattern from there. We go to Ocean Beach in the San Francisco area. Same sort of pattern. Swell heights 15 feet. It might be a little on the high side. That would be on Tuesday. Next one pulling in about 14.5 feet on late Thursday. Most of this hitting after dark. Then a downward pattern there. Winds not too bad for both these events, but again, this is the GFS model. I think it kind of undercalls the wind. You got to go to the high-res models. Yeah, you can pick around on stormsurf.com in the weather model section. The NOM model, I think, does a much better job of near-shore winds. It has a much higher resolution and better land topography, so you can get those sort of Venturi effects that happen around points and stuff. It picks up on that, where the GFS is pretty dumb and not very detailed in regards to that. Anyway, swell heights 10 feet at 15 and a half seconds on the first swell on Tuesday. Next one also about 10 and a half feet at 13 to 14 seconds on Thursday. I think that period's a bit undercalled there, and then sliding down. But the point is, you just look at this right across the board, just looking as you do here, and it's a steady swell pattern, at least for the next week. Then we go down to San Diego. The issue there, of course, is the Channel Islands blocking it. And the more north angle the swell, the worse the blockage. I mean, you really need like 290 or less to have 290 degrees or less to really have a decent chance of getting some exposure through the Channel Islands. So surf heights, 2.5 feet. There we get a little pulse here on Wednesday. That's that first swell, maybe 3.5 foot surf. And then on Friday, the second pulse in the 4.5 foot range. Winds kind of blowing, kind of onshore, not perfect, but, you take what you can get. Surf heights, where we go here, 2.5 feet at 15 seconds on Wednesday, and then on Friday, 2.5 feet at 16 seconds. So at least some longer period energy if you can find a spot that isn't so protected. And the longer period, though, it tends to drag on the bottom and get kind of cut off by the Channel Islands even more so. So take that under advisement. North shore of Oahu, first swell pushes in on Monday, 7.5 foot surf, and that's 7.5 foot Hawaiian, maybe 10 foot faces sort of thing, up to 10 feet on Wednesday, and then trickling down from there, maybe building up again as we get into Sunday in the 5 foot range. Swell heights, 5.2 feet at 14 seconds sort of deal. Second swell, 6.7 feet at 14 to 15 seconds. And then this other one, 3 feet at 16 to 17 seconds on Sunday, a week from now. And then Pensacola, and you say, why are we talking about Pensacola, the Gulf of Mexico? Because there is was a tropical storm. I'm not even sure how strong it is right now, but it's still circulating south roughly of New Orleans, and, with 35 knot winds, I think is what I saw. Surf heights, 3.7 feet, fading down into Tuesday, but then potentially coming up again on Wednesday. That low slowly fading out. I mean, it's a perfect scenario in the Gulf of Mexico to have a low not going anywhere, just circulating in the Gulf, producing fetch and theoretically surf for spots in the Gulf of Mexico. So for people that surf there, it's a bit of a heyday. Swell sizes, let's go into Monday. 3.9 feet at 7 seconds sort of thing. And then another little pulse out here at 5 feet at 6 seconds. So surf indeed for the Gulf Coast. And then Cocoa Beach, Florida, on the east coast of Florida, there's been steady onshore flow, east to northeast winds, surf heights, 3.5 feet into Monday, coming back up on Wednesday, 4 to maybe 4.5 feet, and then another little pulse as we get out towards the weekend in the 3 foot range. Swell size is 4 feet at 8 to 9 seconds on Monday. The Wednesday event, 5.5 feet at 7 to 8 seconds. And then further out, this is sideband energy really from a low forecast up off the northeast, 2.2 feet at 10 to maybe 11 seconds. So a bit of surf continues along the U.S. East Coast. And now for the long-term outlook. What's going on with the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation? These two weather oscillations are the main influencers. They're tropical oscillations, but they affect both the north and southern hemispheres in the winter and summer months. Mainly, MJO has a pretty marked influence on the North Pacific in winter months, so we are going to dive in there and use that to help explain some of what's been going on for the North Pacific. We'll first talk about the MJO, the Madden-Julian Oscillation. There are two phases to it, the active phase and the inactive phase. They oscillate between each other. The active phase is on one side of the planet, the inactive phase on the other. They rotate on the equator, moving from west to east. So if you're in the Pacific Ocean, you'll see the active phase of the MJO move into the West Pacific, then track east across the Pacific over about a 4 to 6 week period, eventually leaving the Pacific and then moving into the Atlantic Ocean. Wherever the active phase is, it adds energy energy to the jet stream by taking warm, moist air down at the ocean surface, lifting it aloft. Effectively, the active phase is a low-pressure system. It acts like a chimney and sucks warm, moist air from the ocean surface up into the upper atmosphere. That gets caught by the jet stream. It energizes the jet stream, making it stronger. It doesn't split. It consolidates. That helps dig out these troughs that we were talking about and looking for earlier in the broadcast. And then in turn feeds storm development, which in turn makes surf and also makes snow. All right. The inactive phase does the exact opposite. It's a high pressure system. It cuts off the flow aloft. The jet stream gets weak. It splits and doesn't do anything to support storm development. So it's very key to know where the active phase is and how long it's going to hang out, because that gives you some good sweet spots to know when the odds. It's not a guarantee, but it stacks the odds in favor of storm development in your ocean, depending, of course, how you're oriented and all that kind of thing. All right, we're going to start by looking for signs of the active phase of the MJO in the Pacific. We're using data from the TAO buoy rays. There's a buoy strung across the equator, East Pacific here, West Pacific here. We're just looking at the arrows here. The colors are sea surface temperature data. We're not concerned with that right now. But we're looking at the arrows, pretty strong out of the east. These are trade winds, five-day average winds. So strong trades in the east, strong trade. The date line is right there. The equator is right there. This is the East Pacific, West Pacific here. That is New Guinea. Trade strong in the East Pacific. Trade's pretty strong here in the Central Pacific. No, notice they're lighter here in the West Pacific. That is a little bit encouraging. But it is not the actual wind speeds that really matter. It's the anomalies, the difference from normal for this time of year. You see here, you're looking at the arrows. There's really no arrows. So these strong east trades, that's pretty much normal for this time of year. Same thing over the Central Pacific. In the far West Pacific, this is really the area when the active phase, remember, it moves from west to east on the equator. So when the active phase moves over here, and again, it takes like 6 weeks, 4 to 6 weeks to make this transit here. But when it moves here, that's where the chimney starts pumping warm, moist air up in the atmosphere. It starts feeding the jet stream here. So as the jet stream moves downstream, then it has energy so it can dig out these troughs and make storms on the dateline and in the Gulf of Alaska. So this pattern here suggests neither really the active phase or the inactive phase. If the active phase was in effect, you'd probably see some flavor of westerly anomalies. In fact, I think in our last video and the video before that, so that'd be 2 weeks ago and 3 weeks ago, respectively, there were westerly anomalies over here, suggestive of the active phase of the MJO. But now it looks like that is not occurring, and we'll dig into what that's all about in a second. Here's the zonal wind forecast for the next 2 weeks from the GFS model for the entire planet. All right, and you can go back in time here. So the reds are westerly anomalies, the reds and oranges. The blues, easterly anomalies. So you see here back, this is the whole planet. So the date line, 180 west, runs right down the middle. So that's right smack in the middle of the Pacific Ocean. Far West Pacific starts about 125 east. So from there to about here is where the real important area is in terms of doing that magic with the jet stream. I call it the Kelvin wave generation area. So if you look down the center of the picture, you see there were easterly anomalies. The blues and purples are easterly anomalies. This is loosely associated with the inactive phase of the MJO. The inactive phase of the MJO, like a high pressure system, that in turn feeds trade winds. Trades are typically out of the east. And so this means enhanced trade. So this was probably the inactive phase of the MJO in the Pacific in the early part of October. But here are the westerly anomalies moving into the Pacific the end of October, right? And have been transiting their way across the Pacific and are pretty much out of the West Pacific as of today. So this was this sweet spot. And remember when we looked at the Hindcast wave model, how it was just storm after storm after storm and a building pattern as we got into the fall? Yes, the fact that we were moving into fall helped it, but the active phase of the MJO, which was in play during this past couple of 2 or 3 week time period, I think was aiding the storm production machine. You see from now for the next 2 weeks, easterly anomalies in control of the West Pacific. Looks like the inactive phase of the MJO. Let's dig into this a little deeper. Next up, outgoing long wave radiation forecast. It's just fancy words for cloud cover. If you have more clouds than normal, well, if you have the active phase of the MJO, it's taking warm, moist air, pushing it up into the atmosphere. That warm, moist air is going to hit cold air aloft and create more clouds than normal. This chart here shows the blues as more clouds, cloudier skies. The oranges and reds, or oranges and yellows, less cloudy. So this would be the inactive phase of the MJO. And let's get ourselves oriented here. South America, Central America, Hawaii, EQ, the equator, dateline right there. This is the Pacific, West Pacific. So according to this, the statistic model, we have clearer than normal skies, which can be loosely associated with the inactive phase of the MJO starting to set up in the West Pacific. And remember the previous model we just looked at, building easterly anomalies, again, sort of supporting that thesis of inactive phase of the MJO in control. Go out 5 days, same deal, 10 days, 15 days, with the active phase trying to rebuild in the Indian Ocean. The GEFS model, the GFS ensemble model, pretty much painting the same picture, though the active phase not as strong. Phase diagrams for the same two models, statistic model here, dynamic model here. The heavy dot is where the active phase is. Now, how do you read this? Well, the MJO moves from west to east around the planet. So this chart tries to map where the active phase is. The MJO moves from west to east from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across Africa, back to the Indian Ocean. So the active phase, as of right now, is past. You can also actually see it here in October. Active phase on the, let's say, the 21st of October, working its way into the West Pacific, transiting through the West Pacific through Halloween, and then exiting the Pacific as we got into November. Now, it's not quite as clean as the way, this is literally a point on the map, and the MJO covers thousands upon thousands of square miles, but it gives you sort of a sense of where things are going. So here's where the active phase is now. We'll say over East Africa right now on the equator. Okay, and the forecast for the next 2 weeks has it moving to the East Indian Ocean. So it looks like on the exact opposite side of the planet, the inactive phase then would be making its pass through the Western Pacific for the next 2 weeks. The dynamic model, this is the statistic model. The dynamic model basically painting the same picture. Then we dig in a little deeper with yet another model, the CFS model. This goes out a month. So we're using a statistic model, the GFS model, which is sort of the global short-term model, the CFS model, which is the long-term multi-season model, to get a sense of what's going on. Again, the same deal. The west the west component of the wind is the reds. You can kind of see something that looks like the active phase maybe transited here. Then you see blues here and the dotted contour. MJO is the dotted contour. That when it's dotted, inactive phase of the MJO. When it's solid, here's the active phase, and you see the reds, the westerly anomalies going across the Pacific. Again, dateline right up the middle, far West Pacific 125 east, so there. And then, so here is today's date. Again, that same pattern as we got into the middle of October. Active phase of the MJO passed over the Pacific, and as soon as that happened, we started getting gale after gale after gale, first in the northern Gulf of Alaska, and now we're deep into it, setting up on the dateline. But as you see, the next 1, 2, 3 weeks at least, here come the building easterly anomalies and the inactive phase of the MJO, making its transit across the Pacific pretty much into the early part of December. But look way out here, if you believe this, a strong active phase is to be building in the Indian Ocean and likely making its way into the Pacific as we get closer into mid to late December. So for right now, this sort of suggests a quiet period. Yes, we have storms still on the charts. The MJO does not mean that you will not have surf or you will not have storms, but it sort of changes the modality of those storms and changes their character a bit. And again, you get some hangover from this active phase of the MJO, but a week from now, as we get to the end of the model, it's going to be real interesting to see what happens as we get into this time period in terms of storm and surf production and rainfall production. My guess is the amount of storms we're going to get and the amount of surf we're going to get, it's going to be backing off from what we are currently seeing, still under the influence of the active phase of the MJO. But I want to know what's going to go on beyond that. So fortunately, the CFS model, like I said before, goes out many months. How believable it is? Well, you take it with a grain of salt. But all right, here now, this is past performance on this rendering of the CFS model. This is the forecast here. Blues, easterly anomalies, oranges, yellows, westerly anomalies. Dateline runs right up the middle. The far west Pacific starts at 125 east. So here you go. Here's today's date. You see easterly anomalies pretty much starting to build today. Forecast going through about the 1st of December in this model. Then the nice thing is here, look at this. You see westerly anomalies forecast early in December and continuing to build over the Pacific the whole way into the end of January and February. I mean, this looks very promising. It's been on the models for months now. How believable it is, hard to say. But what this does hint at is, notice after this, the pattern, there seems to be a regime change in the Pacific. You had these periods of easterly anomalies, easterly anomalies, easterly anomalies. Then all of a sudden it shuts down. Is this the end of La Nina here? Well, I'm not going to claim that because this is way too far out into the future. But it is a tantalizing little tease here. Let's overlay the MJO. All right, so here is our active phase of the MJO that's fading out now as it moves really south of California's at 120 west. It's moving south of California. Again, wherever the MJO is aligned, north or south, that's where the weather is going to be. Rain in the Sierra, snow in the Sierra lines up perfectly with the MJO moving south of California for the next week or two. So just keep that in mind as well. Anyway, here is our building inactive phase of the MJO. This rendering of the model says it hanging over the dateline till about December 5th or 6th, while the active phase starts building in the west right around Thanksgiving time. Now, the sweet thing about this, look at this. It's just solid westerly anomalies over the dateline till almost the end of January. And even after that, you have an inactive phase, but westerly anomalies continue to hang. Easterly anomalies try, but you see just more kind of a neutral pattern. It's almost like something is going to change in the Pacific. And again, the models have been saying that. Let's overlay the low pass filter. All right, so this solid contour, this is the El Nino signal or the low pressure bias. This is the area that would be El Nino if it was over the dateline, but instead it's been over the Indian Ocean and is forecast to continue. Notice this one isobar, this one contour, pushing into the far west Pacific, maybe even to, it's kind of hard to line up here, but maybe even to 150 east. That's making some progress into the West Pacific. That might explain why westerly anomalies hang. And also notice this. So here's the high pressure bias, this dotted contour. If we were in a solid La Nina, this thing should be, multiple contours right here over the dateline, not even close. We get to November 15th, we'll say, and the first real kind of a contour shows up, but it's only one contour. And by the time you get to late January, it's supposed to be even fading. I mean, this is the weakest La Nina I've ever seen. I don't want to say that, but it's really a very weak La Nina, which is a good thing and possibly changing and not even in play as we get deeper into January. Earlier, when we were in the springtime of this year, we were saying, well, it's going to be La Nina. It's probably going to be pretty strong. The early part of the season will be good for surf production because it will have the hangover from El Nino. But once you get deep into winter, it's all going to fall apart. I'm beginning to change that too now and thinking that we'll see how this plays out. But we might get into sort of a pattern where we almost eke out a semi-normal winter surf-wise and maybe even rain-wise and relative to California. Too early to say, but La Nina not looking impressive at all. And now into the real El Nino, La Nina discussion. Subsurface temperature, actual temperatures, data from the TA buoy array. These are the anchor lines on the buoys. The X's are the sensors. Building warm water in the West Pacific, a good sign. The 30-degree centigrade isotherm showing up at 171 east. The 29-degree isotherm holding where it was 2 weeks ago at 180 west. The 28-degree isotherm holding where it was at 170, and the 24-degree isotherm the whole way across the Pacific, but shallow. Actual anomalies, that's what matters. The difference in water temperature, a building area of warm water in the West Pacific. Again, this is a very, very good sign, suggesting that trades are not blowing as hard as they would during a typical La Nina pattern. And you do have some degree of warm water here in the far West Pacific, but more so the cold water anomalies, they're here, but they're not strong at all, at least in this version of the chart. Let's go look at another version. These same data projected, again, this building area of warm water over here in the West Pacific. We'll see this in another chart in a minute. I mean, this is a very encouraging sign. And I just saw some other data that suggests this is actually warm water that's flowing out of the Indian Ocean into the Pacific, which suggests trades are not particularly strong over here at all. Again, all this is marginally and cautiously optimistic in terms of us trying to eke out some sort of a near normal winter in the Pacific. Now, we do have colder than normal water here in the East Pacific. Classic La Nina sign. There's a little patches of warm water, but there seems to be the flow off the West Pacific. This is the track, the thermocline that cold water would follow. It's cut off by warm water here. If anything, it's almost like a Kelvin wave is trying to build here. It's not, but it looks like it is. But it's cutting off the flow of cold water, which means La Nina doesn't have any more fuel to build. It's just sort of tapping out the cold water that's here. This will all make its way to the surface, but there's nothing to fuel a building La Nina. And the fact that, well, it's already November. La Nina pretty much peaks out around Thanksgiving, a little bit earlier than El Ninos. So we'll keep our eyes on that. Here's the satellite data used to also build that chart we just looked at. This is showing the height of the ocean surface. Strip out the wind waves, the swell, the tides. Is the sphere of the ocean higher or lower than normal? If it's lower than normal, that suggests cold water at depth. If it's higher than normal, suggests warm water at depth. Here's that building equator right here, dateline right here. Chile, Peru, Central America, Hawaii, New Guinea here. Building positive anomalies 5-10 centimeters above normal suggests a building warm water pattern here. You can actually see, almost feels like warm water spilling through the islands, trying to get traction in the West Pacific. Cold water, minus 10 centimeter anomalies, but basically unchanged from 2 weeks ago. Again, suggesting this La Nina is not getting traction. Still, below normal anomalies almost to the date line suggests there is colder water at depth. We are not even in a normal pattern, but not some sort of dramatically building La Nina pattern at all. Upper ocean heat anomalies. This suggests how much warm water is in the upper 300 meters of the ocean surface. West Pacific here, East Pacific here. In time, going back a year, that's our last Kelvin wave from last year's El Nino. Here was the beginning, the cool water, making it from the West Pacific to the East Pacific. 1, 2, 3, 4, 5 pulses of cold water. Here's where we are today. Notice these extra cold pulses, all but gone. Notice the building warmer temperatures over here, creating a blockade, preventing this cold water pattern like there from forming. This is like almost a Modoki La Nina, if you want to try to equate it that way, a sort of La Nina, but not really. Again, that's a good sign for us in the Pacific. And then, of course, what really matters is not subsurface. That sort of is the foundation. But what's going on at the surface? How much expanse of colder than normal temperatures are there on the equator? South America, North America, Hawaii, New Guinea here, the equator right there. Dateline here. Here's our colder than normal water. Patches of it, warm water interspersed. It's really the area from 5 degrees north to 5 degrees south on the equator, from 170 west to 120. So you build a box right there. That's kind of the definition of the main La Nina region. And yes, it looks La Nina-ish, but it doesn't look horrible at all. Also notice the warm pool here. This is the cold phase of the PDO inflow. Dead air here, high pressure in control, pushing north winds down the U.S. West Coast, typical of a cool phase of the PDO. I say that because between the Hunga Tonga volcano erupting and sending aerosols into the air, the failed, I'll call it literally a failed El Nino. There is from last year, there's a lot of latent heat energy buildup in the atmosphere, and then warming oceans and planet. There is a lot of latent heat energy in the atmosphere that needs to be released. And the question has been, and I'm not going to go there, but the PDO, when is it going to switch? It seems like we are very close. 7-day trend, yes, pockets of cooling waters for the last 7 days. A week ago was pockets of warming water with the inactive phase of the MJO likely building over the Pacific. La Nina is going to get one more, pulse of cooling to feed it. We'll see how far it goes, but the next 3 weeks are pretty critical as to how strong our La Nina is going to get. I'm going to be cautiously optimistic, but I'm not even going to say it because I don't want to jinx it. Sea surface temperature trend in the Nino 1.2 area. This is right up there along Ecuador. This is sort of the feeding area for El Nino and La Nina. Temperature's up a little bit, 650 thousandths of a degree below normal. Again, not even, at least in the past couple of days, not particularly strong at all. But you see, we have been hovering down in the 1 to 1.5 degree range since, we'll say mid-September and beyond. But in the Nino 3.4 region, the official El Nino monitoring area, well, here's temperatures today, 655 thousandths of a degree below normal. At half a degree, that's the threshold for the start of La Nina. When you're between half and 1 degree, that's considered weak El Nino. And basically, that's where we've been, and only since late September. So what, a month and we'll say a month and a half. You got to be there for like 5 consecutive months to really declare La Nina. Yeah, officially, I think we are in some sort of a weak La Nina state, but it is so bare minimum right now. And that is good news in terms of precip into California and maybe some hope for our winter surf season in the North Pacific. Real quick here, the October 30th official weekly sea surface temperature anomalies for the Nino 3.4 region right here, only 0.2 of a degree below normal. So you're in, and looking back, we only have 3 weeks right there that we've been even close for just a week in La Nina territory. So that's something to really chew on too. And then finally, the Southern Oscillation Index. This is an indicator of what the atmosphere thinks is going on. Are we in La Nina, El Nino, or something neutral? It's the difference in pressure between Tahiti in the basically central equatorial Pacific, and Darwin in this basically the same location over in the Indian Ocean. When pressure is lower in Tahiti, then consistently the index goes negative. Today's value, well, plus 4.83, but then you look back here, well, we've been negative for maybe 10 days or so. And going back the past month, I mean, just toggling, not really strongly one direction or the other. The 30-day average here takes into account, sort of evens out, because this is pretty rough. Things can happen. You have local low pressure systems over Darwin or high pressure over Tahiti or whatever, and it can mess things up. Today, 0.95. That's basically neutral. Where have we been? Well, we got up to 5.23, but then, for the past month, we're basically dead neutral. This shows, at least to me, no real signs of La Nina. The 30-day moving SOI, let's average it out even further, 3.87, and where have we been? Well, we're up a hint, but until you're in the plus 10 degree range, that's where I'd say you start moving into La Nina, and it's got to be there for a while. Let's go look at a graph. Here is the data graphed out. If you're in the blue, you're in La Nina. If you're in the orange, you're in El Nino. Here was our El Nino during 2023. pretty weak one. It didn't go deep, didn't stay there long. And by March of this year, or even before that, by December, it was already over and we were hovering in neutral territory. Today, basically dead neutral. This is showing no signs of La Nina, though I think we know, just, you know, if you've been following the weather for any length of time, you feel that there is some sense of La Nina or a cold PDO pattern in control. Here's the forecast from the CFS model for sea surface temperature in the official El Nino monitoring region, the Nino 3.4. Here we are, we're late, we're in early November. This shows temperatures minus 0.6 of a degree. Well, looking at the data we saw, we're anywhere from 0.2 to 0.5, so this is probably overhyping it. And this is the PDF corrected one. It shows temperatures going down to minus 1.1. I think that is, at this point, pretty much silliness. The consensus model won't post next week, but it'll be the week after that. But it's been consistently showing temperatures maybe going down in the 0.7, maybe 0.8 range, which is at best a weak La Nina. So far, everything seems to be pointing to a very weak La Nina, and as soon as you hit in January, it's falling apart, and we're back heading towards neutral by springtime. So for right now, we have a series of gales pushing through the North Pacific into the Gulf of Alaska. Swell is on the way for Hawaii and the U.S. West Coast. Nothing huge, nothing epic. It's still relatively early in the season. We are in, well, we are coming out of the active phase of the MJO. The title of the video was asking about what's the MJO doing? Well, it's probably been feeding the storm track of lately. As we get into the inactive phase, it's going to be very interesting to see whether the storm track continues or it falls apart. And I'm just talking about the next 2 to 3 weeks sort of thing, because a strong active phase is forecast after that once we get into later November and all December. And after that, I think if that active phase builds as strong as forecast or even remotely close to it, it might just be the end of La Nina and we'll sort of flop over into a La Nada type situation, just maybe a neutral kind of pattern. But this then also begs the question, what's going to happen with the PDO? It's been extremely negative, extremely cold. I read the original paper on the definition of the PDO just the past couple of days, and it really harps on the fact that when the PDO changes, it does it quickly and dramatically, and that the PDO typically runs in 20 to 30-year cycles. We have been in the cold phase since January of 98. So we're at the 25, 26-year mark already, with the Hunga Tonga volcano spewing now what they're saying was actual aerosols up, which caused the planet to cool a little bit. That further, sort of feeds the La Nina PDO pattern. But those aerosols typically, they wash out after about 2 years, and we're 2 years into that cycle now. And I'm beginning to wonder if the aerosols are going to fade out, La Nina, because it's so weak, is going to fade out, and all of a sudden, maybe we'll get the flip. In the PDO. I don't know that that's going to happen. I mean, that's very wishful thinking. I think a more realistic thought is, well, maybe we'll resurrect out a normal or fairly normal winter relative to where we've been the past 5 or 10 years, where just nothing really seems to stick, all because the PDO has been so cold and so negative. If we can get out a regular, normal, and then also get snowfall and rainfall over California and into the Sierra, and even get 85% of normal snowfall, which I think is highly achievable, I would call that a roaring success for this year. All right, that's the video for this week. If you enjoyed it, give us a thumbs up. If you haven't subscribed, please subscribe down below. Comments or questions are always welcome. If you'd like to make a contribution, you know how to do it. Hit the special thanks button down below. And with that, we are done for this week. We will do it again next week. Same time, same channel. Thanks so much for watching. See you next week.